Thank you very much for that introduction. Today we're going to be looking at fear. We're going to be looking at the fear of nuclear power, a fear that is deeply ingrained in our collective memory. We're going to be looking at it from a perspective of climate change and how this has come to impact the way that we address it. So today's agenda will be, we're going to look at why one actually should care about nuclear power in the first place. We're going to be looking at the theory of securitisation, a theory that will be giving us a framework through which we can look at the issue at hand. We're going to be looking at the actual securitisation of nuclear power, its causes, but more importantly, its consequences. And we're also going to engage in some myth-busting and some concluding remarks. So why should you actually care about all this? I think that is quite simple. You should care because of this. And this. And this. Last year marked yet another temperature record, 1.02 degrees of climate warming. And the trend cannot be mistaken. Our planet is gradually, step by step, heating up. And that's something we should be incredibly worried about. And to reinforce this notion of urgency, let's go back 4 years to the annual report of the International Energy Agency that said that if action to reduce CO2 emissions is not taken before 2017, all the allowable CO2 emissions would be locked in by energy infrastructure existing at that time. So what does this actually mean? Well, put it simply, unless we take radical action before 2017, we will have lost any kind of room for manoeuvring. That is, we cannot continue to increase our CO2 emissions. That's 10 months from now, and no radical action has been taken, which means that us reaching the 2-degree target is becoming increasingly difficult. So time is of the essence, but it is running out. Our scope for manoeuvres has pretty much evaporated. And we need radical action. Nuclear power as an energy source is incredibly powerful. It produces CO2 neutral energy. Yet it's so politically toxic that it's automatically disqualified from playing any kind of significant role in the policy toolbox. So why is that? And this is where the theory of securitisation comes into play, a theory looking at how do we frame threats as existential threats to not only the government, but to the public itself. And it's a fairly complicated process, but in the interest of time, we shall strip it down to the core tenets. And it starts off with an actor. An actor can be the government, can be the general public, it can be a politician. What they have in common is they are regarded as an authority. They will identify an issue as posing such a threat to the very survival of the state. The next step is that the issue would be presented to the audience. The audience, as Jamie said, varies. It can be the general public, it can be Parliament, or any other section of society. But the actor has to try to convince the general public that this is indeed a threat. If we don't do anything about it, we're not going to survive. That's the basic premise, and then it's presented to the audience. And there are two outcomes. The first outcome is that the threat is rejected. The audience doesn't agree that we do not need to take any extraordinary measures to alleviate the threat. This is not the case with nuclear power, and we don't have to delve too much into that. The other option, however, is that the general public or the audience accepts this as an existential threat. If we don't do anything about it, we shall not survive. That is securitisation, and that means that extraordinary policy measures that otherwise would be deemed too extreme by political constraints or other factors. So let's look at a case study. Let's go to Germany in 2011. And remember, ladies and gentlemen, that fear is the prime agent here. So let's combine people's fear and perceptions of nuclear weapons, a very real fear that's been around ever since the bombing of Hiroshima and Nagasaki. Combine that with the public's mistrust in nuclear power and spice that up with the conception that a nuclear power plant can explode just like an atomic bomb, perception that has no grounding in science but very commonly held. Mix in a disaster, bring the urgency to the audience, and in the German case we had Fukushima and the televised imagery of nuclear power plants seemingly exploding in a developed world brought it home that maybe this can happen in Germany too. And this is what the actors are advocating, that if it can happen in Japan, it can happen here. And the outcome is that it became securitized. The general public agreed that nuclear power poses such a threat that if we don't do anything about it, it's going to wipe us all out. So what was then the extraordinary policy measures taken? Well, Germany decided they're going to phase out all nuclear power by 2022. Many nuclear power plants were never even restarted after 2011, and those that were, closing down in 2022, could easily run into the 2040s. So then, what were the consequences? Nuclear power, as I said, incredibly powerful, a lot of energy that's been produced in an efficient manner. Renewables was heralded as the way to replace it. However, renewables, due to its very nature, the sun doesn't always shine, or there's too little wind, or in the Scottish case, too much of wind. And you have to have an energy system where you can always produce energy. You just flick on a switch. So, in the German case, up until 2011, greenhouse gas emissions were steadily declining in Germany. Come 2011, nuclear is removed, you have a shortfall. Renewables can plug the gaps to an extent, but by and large you have to replace it. You have to replace it with coal. And not just any coal, lignite or brown coal, one of the worst polluting sources known to mankind. And the consequences are obvious. CO2 emissions are on the rise again. Statistics for 2014-15 are likely to be going in the same direction. So then, take a step back. Let's look at some of the previously held conceptions of nuclear power as a power source so dangerous they will kill us all. And the two accidents that have been incredibly important to create this notion. Let's start off with the Chernobyl accident in 1986, the worst of the worst. NGOs, such as Greenpeace, has estimated that 200,000 people, or even more, will have or is going to die due to the accident. The United Nations is predicting between 2,000 and 4,000. But ladies and gentlemen, the actual number of confirmed deaths as of now is 62. On top of that, we have about 6,000 reported cases of non-lethal thyroid cancers, all treated. And as you see, there's a clear disparity between what NGOs are saying and what the UN is saying. And the NGOs have used very sketchy models. When you use very sketchy models, you get very sketchy statistics. But this is statistics that's very helpful to reinforce the notion that, look, one reactor could easily kill hundreds of thousands, if not millions. But it's based not on truth and science, but on sketchy models. And that's a problem here. And that is also undermining one of the few options we got to decarbonize our electricity system. Let's take another one. Let's go to Fukushima 2011. The number of individuals that died due to the earthquake and tsunami that subsequently led to the catastrophe itself was 15,893. So far, Fukushima has claimed 0 lives. However, the entire narrative that was created during the time of the accident, I'm sure most of us remembers it, was that, look, there's a power plant here in grave danger. It might explode. It might wipe out Tokyo, kill 30 million people. That's the narrative that was created and sold to the general public. And in the German case, the general public agreed. It does not correspond with reality, but it doesn't have to. That's the dangers of securitizing an issue. So let's have a bit of another example. Surely you would never say that this, one of the world's oldest computers, fitting in a decent-sized living room, would be the same as this, a modern computer. 50-odd years of development that's been put into this. So why then would we say that the reactor designed in the 60s is the same as the reactor designed in the 2000s? Why would we base our perception of this because of that? It does not correspond. The facts do not correspond here. And let's look at some energy equivalents. Imagine, ladies and gentlemen, that this is a lump of uranium. This lump will be enough for my combined life's worth of energy. All I need. But let's say we do not use uranium. We use gas. You will need 56 of those trailers. Line them up, almost 2 kilometers long. Let's go maybe renewables. You need to store them. You need batteries. And you wouldn't need one battery of the size of the Empire State Building, not 2, but 16. Pile them onto each other, almost 5 kilometers high. Or if you use coal, it'll be not one bag of the size of an elephant, but 800. But due to this irrational fear, we decide not to use this, but this. And there's a more grim side to this as well. When we replace uranium with coal, as seen in Germany to a large degree, it will cost people their lives. Nuclear power costs about 90 people their lives per terawatt hour, coal 170,000. And we have to owe up to the fact that our way of living is unsustainable. The world's population is steadily growing. They all have the same rights as we do to have all the energy that they want. But if they're going to go through the same development as we do not stand a chance in hell to be able to achieve 2 degrees, 3 degrees, 4 degrees of climate change. We're talking about 5 to 6 degrees of catastrophic climate change. And ladies and gentlemen, we are living, due to the way we live, in the 6th mass extinction event. I think Al Gore summed it up well when saying that when we flirt with despair about the future, we're less likely to take the actions necessary to safeguard it, focusing on the short term. And that's what we see in Germany. A short-term fear of nuclear, get rid of that as a short-term solution. The long-term problem of climate change is not alleviated. It's made worse. So modern nuclear power holds the key to providing a better and brighter future. However, we must challenge this culture of fear, the lies, the deceit that's surrounding nuclear power. And if we do that, and if we bring nuclear power back from the cold, we have a fair chance of stopping the climate crisis that is threatening our very existence. And that, ladies and gentlemen, is my message today. Thank you very much.
It seems quite pessimistic, I guess. Would you say that sort of could reverse the process of securitisation, that we might sort of stand a chance at actually sort of stopping this sort of tide of climate change, I guess?
Yes, I definitely agree with that basic notion that if we start to use nuclear power, de-securitise it, as it's called, we stand a chance, because nuclear power, especially modern generation 3.5, 4 reactors, are incredibly safe. They've got passive security features, so you can just leave them and they will shut down safely. They produce CO2-free electricity to the same extent that solar and wind does. So if we can reverse the processes, we do have a chance, because we need to very rapidly decarbonise our energy system. We need to remove coal, we need to remove oil and gas, and renewables can remove a certain degree, but by and large it has to be nuclear power or fossil fuels.
I think, like, I come from Finland and you're very big on nuclear power, but one question that dominates the debate is obviously what do you do with the waste, because it seems like that's the central issue and the catch with nuclear power.
Definitely, very good question. I reject the notion that it is waste. I see this as a commodity that we can be using. A modern nuclear power plant, most of them, have the fuel, they run it through once, so you use approximately 2 to 3% of the energy content of the uranium, and then you bury it. I think that's an absolute utter waste. What we can do, there are modern reactors designed in the United States that have been proven, have been running for 30 odd years, where you recycle the fuel, you burn up the really nasty poisonous elements that we have to bury for hundreds and thousands of years. And if we then take the bold step and adapt more modern nuclear technology that's suited for the 21st century, we'll recycle the vast majority of this, making the need and the sheer quantity of nuclear waste much, much smaller. And it will not have to be buried for nearly as long.
We talk about Germany today.
Yes.
That, okay, we all trust Germany that passes all the tests of sustaining these nuclear facilities.
Yes.
What about other countries like Bulgaria? Can we trust these tests? Like, what happens if they don't take care of all of these facilities? Are we safe?
Are you talking about existing nuclear facilities? Or yes. By and large, most modern nuclear power plants are extremely safe. The ones that aren't are designed in the Soviet Union, same as the Chernobyl type. Those reactors has to be shut down. Lithuania had to shut down an almost identical reactor to even be able to admit it into the EU. So you can trust nuclear power, and it's proven that it is a lot of scaremongering going about, and it is the best way for countries like Bulgaria to meet its climate change obligations, because otherwise you have to replace it with coal. So it is safe, and I think that the industry deserves some credit for all the hard work that's actually been putting into it.